going. All right. So, yes, this is our introduction to calculus, and yes, the three major topics you're going to learn are limits, derivatives, and integrals. Okay. Derivatives is actually the process of doing differentiation, if you want a fancy name for it. You don't have to know that. Integrals we will call the process integration when we get there. Okay. However, everything you do, everything in calculus comes back to the concept of a limit. Just like in trigonometry, the answer to what should we do if we don't know what to do was what? Draw a picture. The answer in calculus, if you're stuck and you don't know what to do, is use a limit. Over and over and over. The first thing I taught them in calculus this year was limits, and the last thing I taught them last week as far as new material involved limits. They never go away. So limits are pretty crucial. That worksheet I gave you is all about limits. That's primarily your limit homework here. The big thing, what limits do differently, we don't know how to find the value of a function. If I say to you find f of 2 and I give you some function, how do you find f of 2? You fill it in the function and you get the value out of it. Okay, so we know how to find the limit at or we know how to find the value of a function. Limits, the big thing is right here. They're concerned with what your y coordinate, because when you fill x into a function, you're getting the y coordinate. They want to know what the y coordinate is getting close to as your x coordinate approaches a number. It's all about what happens when I get close to something, not when I'm smack on it. Limits are the whole idea of getting close, and you have to see it done a few times before it makes sense. Okay. The notation for a limit, you'll see LIM, and below it, there will be x with an arrow. We read that as x approaches negative 3. Now, you'll notice I have on here x approaches negative 3 times, but they're all different. There's a negative 3 with a little minus behind it. There's a negative 3 with a little plus behind it. And there's a negative 3 with nothing behind it. Well, what does that mean? Okay, in the land of calculus, a negative behind it, negative numbers are on the left side of our coordinate system, so a negative means from the left side. A positive behind it means come from the right side. Nothing behind the 3 means come from both sides. So we need to talk about this. I want to do the limit here. This first one is x approaches negative 3 from the left-hand side. You're looking at this graph, and you're asking yourself, okay, what's happening as I approach, I need a bright color here, as I approach negative 3 from the left. So as my x-coordinates come toward negative 3, what are my y-coordinates doing?
Going down?
Yeah. So I'm going to start way out here. This x-coordinate, my y-coordinates clear up here, probably what, 2, 4, 6, 8, it's about 8 high. When I move over a couple x-coordinates to negative 5, no, that'd be negative 6. Now if I go up and find the y-coordinate on the graph, now my y-coordinate's about in here, so it's come down some. What we're asking is, what happens when my x-coordinates get over here really, really, really close to negative 3? What are my y-coordinates getting really, really close to? Okay, I got an answer of 4, because this is 4 right here. Okay, there's this hole sitting at 4. But there is no value of the function exactly at negative 3. That's a hole. There's no value there. But we aren't asking what happened on negative 3. We're asking what happens when it gets really, really, really close to negative 3. So if this x-coordinate gets really close to negative 3, what are those y-coordinates getting really close to? They're getting close to 4. They're getting really close to 4. Who cares what happens right on the point? We don't care. We only are asking what happens when we get close. So in this case, we would say the limit as we approach negative 3 from the left side is 4. Okay. Then you're going to go do the exact same thing, except now they want to approach negative 3 from the right-hand side. So pick some x-coordinate over here to the right side of negative 3.
Right.
So and you don't have to go way out there. In fact, you don't really want to go way out there. But you're asking yourself, okay, if I start even at 0, whoops, that's not red anymore. If I start even at 0, my y-coordinate is down at negative 2. But as I move over, when my x-coordinate is at -1, my y-coordinate is almost right there at 0. When my x-coordinate is at -2, my y-coordinate has risen up almost to 2. So what's happening when I get really, really, really super close to -3? Where is that y-coordinate? Yeah, it's up here going toward that same open hole again, isn't it? So therefore my limit is getting close to 4. So what if there's a hole there? Limits don't care what's happening on that point. All right. So now, the third one is they want the limit from both sides. Okay. So for there to be a limit from both sides, the two sides had to come to the same number. In this case, did both sides go toward the same number? They went to 4. They both went to 4, didn't they? So therefore, the limit from both sides is 4. So it's when it says x approaches -3, it means if you're coming toward -3 from both sides, if your x-coordinates are coming in there, where are my y-coordinates going? The key thing is you're finding where the y-coordinates going. Okay. Then, last but not least, they're going to ask you, what is the value of the function right on -3?
No, he's undefined.
There's a hole there. So what do you call it when there's no point? Somebody said it. Undefined. Yes. Undefined. When there's no point there, we say it's undefined. And yeah, there's a hole there. So we have an undefined value at that point. So it doesn't matter. There can still be a limit even if the point itself is undefined. All right. Now, let's try another number. Suppose this time I want to approach +1 from what side? The negative means I'm coming from the left side. So if I'm coming toward +1 from the left side, so you don't have to go way out. I would just go a little bit over. I'm on the left side of 1. Okay, if I start even at 0, where are my y-coordinates at? They're down. Find the graph. It's down here at -2. As I move closer in toward 1, where are my y-coordinates going? They're going down. And as I get really, really, really close to 1, where will the y-coordinates be really, really close to? They'll be coming, when I get really, really close to 1, they're down here yet, -6. So we would say the limit from the left side is -6. Now, when you go from the right side, are you following the same branch of the graph?
No.
Yeah, this happens to be a piecewise function. If I'm over here on the right side of 1 now I'm following this totally different piece. It has to be the piece right above or below where you're at. So I'm now down here, and as my x-coordinates move toward 1, what are my y-coordinates moving toward? They're moving toward that hole, which is at -7. So my y-coordinates are getting really close to -7. That's the key thing, is they're getting really, really close to -7. Okay, so now, what's the limit when I approach 1 from both sides?
Can you have them since they're not the same?
Ah, there's the question. Since they're not the same number, can you say there's a limit from both sides? Yeah. How do you know those words?
So mean you're like math is always not good when the math is consistent.
Oh, really? Cool. Actual math in a movie. Yeah. Does not exist. We abbreviated DNE. Yeah, it can't happen. You cannot have a limit for the left side and the right side if it's not coming to the same number. They have to agree. If the left and the right do not agree, we call that does not exist. So, yeah. If the two sides don't agree, you write DNE and you're done. Does not exist. Okay, notice there's a difference. When the point is not there, it's undefined. When the limit is not possible, it does not exist. You have to use the right terminology. It's not interchangeable. Undefined means there's no value exactly on that number. Okay, so in this case, when I ask you for f of 1, when I ask you what is the value right on 1, is there one? Yeah, because there's a colored in point there. On 1, it's colored in at -6, so yep, this baby is, it's -6 then. So you can have, in this case, we have a defined point, but we don't have a limit, because the two sides don't go to the same place. Oh, we haven't done yet? It's great. You would not believe how many problems this solves. This is like the ultimate concept. I can't tell you how much this solves.
So like fonts that have like asymptotes?
Yeah, well, ta-da, how's about, let's do one with an asymptote, since you mentioned that. All right.
You have one up there.
Yeah, you can have anything you like. In this case, I want to approach +6 from the left-hand side. Don't read that as -6 and confuse yourself. That's a +6 from the left side. So if I'm coming toward +6 from the left side, another color. If I come toward +6, I'm following which branch of the graph? This little chunk in here between 1 and 6. I'm following that piece between 1 and 6. Okay, and I'm asking as I go towards 6. So as these y-coordinates go upward towards 6, I'm going up. My y-coordinates are going up. The closer I get to 6, the higher they get. How high will those y-coordinates get? Yeah. Yes, they're going up to infinity because they're going to keep getting closer and closer to the asymptote but never touch it. So yes, in this case, the limit from the left side is, oops, you can't see that.
Then from the positive side, that would be -3.
No.
Okay.
All right, so let's debate that one. From the positive side, if I'm coming towards 6, +6, from the right side, if I'm coming in towards 6, where is the graph going? Now I'm following this very right-hand piece, but as I come towards 6, you can see these black points. It's going down, it's going down, it's going down, and it's going to keep going down the asymptote, which is going to give me what? That's -infinity. You actually don't have to write the positive. If you just write infinity, it's assumed positive, so no, you don't have to write the plus. All right, so now, you actually don't have to look at the graph to do the one from both sides. To do the one from both sides, you got to look at your two previous answers.
Well, could it happen if one's positive and one's negative?
So, can I have, this does not exist. They have to be the exact same thing. Those, going to positive infinity and going to negative infinity are about as opposite as you can get. Yeah, so that's a DNE again. You cannot do that. You have to be the same. Now, if they were both going to positive infinity, then you would say the answer is positive infinity. Okay, what is the answer to what f of 6 is on this one? What's the point right on 6?
An asymptote.
So what do we call it when there's a point there? It's undefined then. Okay, so that's what the worksheet is. You just basically have two graphs to look at and write the answers. There's no work to it. You just have to look at the graph and figure out the limit.
Okay, that's not so bad.
No, that's not a major big deal. That's what this little white is.
I'm sure whatever else we're learning is going to be
You still haven't entered that video, the video point yet.
Actually, is this a good place to kill this?
Get it?
Yeah, 'cause